So problem 1 says determine the Riemann sum for f of x equals 2x squared plus 3x minus 2 on negative 1 to 1 using 4 subintervals of equal length and choosing evaluation points to be the left endpoints. Illustrate the Riemann sum using the graph below. What are we approximating now? So it wants us to draw what the rectangles would look like. So the first thing is I'm dividing this into 4 rectangles. So I'm going to have one of my rectangles at negative 1/2, one at 0, and one at positive 1/2. So for using left endpoints, then I start on the left, find the height of the function, and I draw my rectangle over and I see that we missed just a little bitty piece of this. Then I go to the next value on the left, draw my rectangle, and I overestimate a little bit here. Then here I go across, draw my rectangle, and here the value is 0, so I get no rectangle. So the area, if I actually calculate the Riemann sum, is going to give me the areas of these 3 rectangles. You can see we just missed this piece altogether. I can also see that the area under the curve is going to be a negative value. So for my left endpoints, I want to plug in f of negative 1, f of negative 1/2, and f of 0. So my widths were 1 minus minus 1 over 2. So they're, over 4, because I had 4 rectangles, and I get they're 1/2 wide. Then my c sub k, well, we don't have to write it in terms of k. My c's, I can actually list them out, are negative 1, negative 1/2, 0, and positive 1/2. So the Riemann sum here from 1 to 4 is going to be the sum of my delta x's times all of my individual heights. So since my width is 1/2, I can just simply add up, this is f of negative 1 plus f of negative 1/2 plus f of 0 plus f of positive 1/2. I can actually see from the graph that f of positive 1/2 is just 0. So if I want to know what f of negative 1 is, I'm going to plug negative 1 into my function and get 2 times negative 1 squared plus 3 times negative 1 minus 2, and I get negative 3. So this is 1/2 times negative 3. Oops, sorry, I'm going to add these together. If I calculate f of negative 1/2, I also get negative 3. And then if I do f of 0, I get negative 2. And so negative 3 plus negative 3 is negative 6, plus negative 2 is negative 8, and I get negative 8 over 2, which is negative 4. So it says, what are we approximating now? And we are approximating the area between f of x and the x-axis. So because we had a specific value for n, we didn't have to set up the generic version of the formula. We were actually able to set up the actual individual heights. So I just had to add all those individual heights up. We can see that this came out to be negative because these were all the areas under the x-axis. So this was actually approximating the net area. And so this number coming out negative confirmed for us that the area was below the x-axis.